Okay, I'm going to do the next page on this video. So number 6 is a toy is made up of cylindrical rings stacked on a base as shown in the diagram. The diameter of ring 1, that's this ring, is 68% of the diameter of the ring directly below it. So this is 68% of this one, okay? The diameter of the base is 8 inches. Which function can be used to find the diameter of inches of ring, which is r, where r is greater than or equal to 1, but less than or equal to 7, sorry. So they love to ask you this question, and what we can do to eliminate automatically is guys, we know the equation, and we're going to keep coming back to it. Because you can figure out 100% of the time what your answer is if you know this. So this one, we know, if we're talking about our rings, right, that the A is always our what? Our starting. So this base is my starting. What is the diameter of the base, right? So Y is equal to, what should my A be? The A should be 8, right? Now, this question was a little tricky. Okay, because a lot of you are gonna like, oh, my percent is 0.68. So first of all, let's eliminate. I know that my A should be 8. So can it be this one? No. Can it be this one? No. Right? So I'm looking at these two. So there's a couple things. We know that the equation is always 1 minus a rate, right? Which a rate is a percent. So it's 1 minus the percent. So by looking at these two options, do we ever take a rate, which is a percent, minus, remember, this is 68%. 68% as a decimal is 0.68, right? So do we ever take a rate, which is a percent, and then subtract it from a percent? No. Okay, this is my percent. This is C. Okay, now, I'm actually doing this one with you. The reason is because, I don't know if you noticed the wording, the diameter of the ring is 68% of the diameter. We know that each ring is getting smaller and smaller, right? Meaning I'm decreasing, right? Meaning we'd be subtracting. But what you didn't know was that they already did the percentage for you, okay? So technically, this decreased by, so what's 100% minus 68%? So what, that's 32% maybe? So it actually decreased by 32, but the wording, they didn't tell you that. They just already did that part for you, okay? They already did it, so the whole B, this whole little parentheses, was actually equal to 68. They already did the 1 minus the rate. They already did that, which is why they got this. But again, even if you didn't know that, guys, you could still eliminate because this one can't work. And this one makes absolutely no sense. They don't even have the exponent. So, like, it cannot work. So please, guys, use your answer choices to help you. Number 7, the population of city center is modeled by the exponential function f, where x is the number of years after the year 2015. The graph is shown on the grid. So they give us a graph. Which inequality best represents the domain of f in a situation? So now I know you're probably saying, well, we know that the domain is what? The x values. And you're looking at it and you're like, miss, it's exponential. It's all real numbers. That's when we're looking at a plain graph, a plain with no scenario. This actually has a scenario, right? We're talking about something real. So we actually have to look at it, okay? I know that my domain, I go from left to right, right? And I know I'm looking at the x's, so I'm only looking here, okay? This is not going to go on forever. This is not going to go on forever this way, because we are only doing time after 2015. So we're not going to go this way, okay? So this arrow, so it's not possible. So this is our starting point, okay? So this is where I come from the left. Boom, I hit right here. And what number is that on the x? 0. So it does hit at 0, right? And it is a closed circle. So we put the line. Then you go all the way to the right. Boom, I hit an arrow. Now, they do give you an arrow, so they're telling you it's going to keep going. So I know that it's never going to stop, meaning it's going to go to infinity. Okay. So we know we don't show infinities. That's not a real thing. We don't show it. So it's like this part's not even here. Okay. So looking at your answer choices, which one can it be? And I can tell you right now, if we rewrote this, putting the x first, right, the inequality is open up to the x, so it still has to open up to the x. Then we put the 0. We rewrite it. Which one can it be? So again, I'm doing this one for you, and that's because, again, we know it can't be D or B because that's looking for the y, and that's range, so it can't be those two. And again, if you read this, this is our starting point, and then it's going to go on forever and ever, meaning it's never going to stop on the x. If you read this, x is greater than or equal to 0. Isn't that true? We start at 0, and then it's forever and ever going to go. So it has to be A, okay? It didn't stop at 110 because of the arrows, so don't let them fool you. It did not. This would have said it stopped at 110, and it did not. So you'll circle your answer for that one. So number 8, which statement about the graph of y equals 1/3 times 2/3 to the power of x is not true? Well, let's look at this. I don't know what this looks like. So I'm going to just take all this off. Okay. So y equals 1/3 parentheses 2/3 parentheses to the power of x. So here I am. Okay, so I see that I notice it's decreasing. I see here that the asymptote's laying under here, right? Looks like it's hitting the y at 0 because my line's not going any lower than 0. Right? If you look at my y values, it's not going any lower than 0. It's getting super close, right? So that must mean that's where my asymptote is. Okay, so what else? So let's look. Now, the graph has a vertical asymptote. What does a vertical line look like? Is it this way or is it this way? Which way? Because I know that my asymptote here runs this way. All right? So what kind of asymptote is that? It should be a horizontal. Okay, so that's not a vertical. Vertical would run up and down, and that is not a feature of an exponential. So that cannot be true. So this one works, but let's just double check real quick. The graph crosses the y at 0 and 1/3. Here, if we touch 0 and 1/3, yep, let me zoom in again. We touch the y-intercept 0, yep, that works. And we all know that 0.33 repeating is 1/3 as a fraction. So that's true. So this cannot be it because we want what is not true. Okay? The graph has an asymptote of y equals 0. That's true, so it cannot be that one. And then the graph decreases from left to right. That's also true. It's coming down. So that one's also true, so it cannot be that one. It has to be A. Okay? Number 9, the student used f of x equals 12,000 times 1.06 to the power of x to show how the tuition at college will increase over time. What does the 12 represent? Hello, a times b to the power of x. So I'm not even going to go any further on this one. None of you should miss it because we all know what the a represents. So you look and read through that, and you tell me, is it A, B, C, or D? Number 10, the number of ants in an ant farm triples every month. Each function can be used to find the number of ants. Which function can be used to find the number of ants present at the end of m months in ant farm if there were initially 100 ants? So again, y equals, we know that A is my initial, so, right? Okay, first of all, have I ever seen a plus anywhere in between? No, right? And I know that what number needs to be the A. This doesn't even look right. I never put a plus between it. Can't be that one. Nope, I need the number 3. Is 3 our starting value? Nope, so look at that. And let's just make sense of it. It's increasing, it's tripling. Guys, remember, everything's with a dollar. If you have $1 and then I triple your money, you now have how much money? 3. So that's how much goes there. Okay, tripling, doubling, quadrupling, that's the number you put there. So number 11, write the first 4 terms of the sequence whose general term is given by t sub n equals 3 times negative 2 to the power n sub n. So, n to the power of n minus 1. So, the first 4 terms of the sequence. Okay, so let's look at, so we're gonna, this is a geometric sequence, sorry, it threw me off, that we did on Monday and you guys killed it, remember? So this is moving at a constant rate, right? So first, and I don't know if you remember the formula, so they gave you the formula, but I don't know if you remember, like, blankly what the formula was. So remember, this was a sub n is equal to a sub 1 times r to the power of n minus 1, right? So a sub n was the first term, and then the r was the common ratio. Okay, so remember, how did we find the common ratio? We went, we went from one to the other, one number, the first number, the second number, and we divided by the previous number. So, like, for example, let's look at, well, actually, first of all, let's look at this. This would be the a sub 1, this would be my r, right, times r to the power of n minus 1. So, the a sub 1, meaning my first term, should be a 3. So, which one has a first term of 3? Okay, so those two. So now let's look at the common ratio. Which one has a common ratio of negative 2? So remember, you divide 24 divided by 12, 2. 12 divided by 6, that's 2. This one, negative 24 divided by, divided by 12 is negative 2. So which one has a common ratio of negative 2? And that's how you find your answer here, okay? So I'll make sure to have this formula written in case you have forgotten it, because I forgot we did that. So that's the second video. Actually, you know what? I'm just going to go on ahead and finish because there's only 3 more problems. So I'll just finish it all on this video. So, and I'll try to do this quickly because I'm running out of time. So the graph of the exponential function is shown on the grid. That's number 12. What is the asymptote of this graph? Remember, the asymptote sits at the bottom, right? And it is a horizontal line, so I know the equation is always y equals. So you're going to look at your answer choices. Which ones can you eliminate? Cool. And remember, you're always seeing it's at the bottom. Where does it hit the y? So this is 1, 2, 3, 4. So what would your equation be? So you guys finish that one out. Number 13, there are 685 games sold at electronic stores in October. Since then, game sales at this store have increased at a rate of 6.2% per month. At this rate, which function can we use to determine the monthly game sales after October? So again, there were 685 games, so that is, right, my A. So I'm looking for 685. So you can look and eliminate, right? Now, this is the only part I'm going to help you on. It's growth. It's an increase. So we're going to add it to $1. We're going to subtract. We're going to add it, right? Now, make sure 6.25%, how many cents is that? You move the decimal twice. So it's 0.0625. Subtract it first. See what you should get, okay? And then once you subtract it, look at your answer choices, and it's A, C, or D. So you decide. And then the last one, 14, a table of values for the exponential function f is shown below. Which situation could describe this function? So by looking at it, we're talking about years since the investment and the value of stock in dollars. So the value of stock in dollars increases by 82 per year. From here to here, does it increase by 82? From here to here, does it increase by 82? From here to here, does it increase by 82? No, and not to mention this is